All right, so welcome back to our chapter 8, apply machine learning to sentiment analysis. Last week, let's look at the chapter. So if we look at the chapter, we discussed a lot, from this, preparing the IMDb review, we go a lot here, but we stopped here from where we can start training logistic regression. So we'll continue from here. But before that, I would just, recap a bit on what we did last week, because what we're going to discuss today is actually dependent on that. So let's take a few minutes to talk about that. So if you remember last week, we discussed about we're going to do sentiment analysis on movie review. So this is a kind of the data given the review on sentiment, classify a review whether it's positive or negative. So that's basically the task. So we said, okay, how can you get the data? This code allows us to get the data, and we go there, we put the data in from our data frame, and after we download the data here with this code, this is the data as we saw there. So this is the data, which with a column called review. The sentiment here is 1 means positive, 0 means negative. We discussed about, okay, this data set, like we have 5,000 rows. If we divide, like we said, like this, or we take this to be the clearance set, it will all be positive. So we say we need to shuffle the data, and that's how we do that. We shuffle the data, and now we can see the data now is like, in 1, 0, it's shuffle, right? So that when we divide the data, we divide, in some kind of stratified format, right? So this is the data. We save the data to data frame to CSV. So if you want to save is to CSV, pandas, stuff like that. And now we load the data. But while we are saving, remember we say index equals to false, because this, we want to reset the index here from this, and now we give it the encoding. So when we save it, we download it, we read it again. You can see now the indexing start from 0, and now you can see it is reshuffled. So why do we reshuffle machine learning data set? Because we want to machine learning data sets to take different samples rather than to be biased by taking only one class. So that's what we discussed. We said, okay, we have been looking at machine learning, doing machine learning, but previously what we were looking is given just numeric values. But now we are using sentiment analysis, which involve text. So given this text, this is determined, this is whatsoever. So in machine learning algorithms don't understand this text. What we need to do is convert this text in this kind of format, kind of numbers, which is called vectorization. So vectorization is a process whereby we take chunk of text and convert it into somehow numbers, which a machine learning model can understand. So this is the way we need to convert any. We said we have different kind of techniques: bag of word, TF-IDF, word to bag, all these stuff. So we start discussing about a bag of word. Given, for example, this text like this. Now we create a dictionary of word from all these given text, and now we identified how many. Now here we have about. So how many about do we have here? 1. We have VAD. How many VAD do we have? We have 5. So in this document, we have this. So also this one, for example, here we have about, but in this document, there is no about, we have 0. So what we mean by document in NLP, we mean a sentence, something like that is called a document. So, this is called a bag of word. We construct a vocabulary. This list of word is called vocabulary, meaning that a list of word without repetition. Because if you look at here, we have a word, but I take only one word, right, from all this one. So this is called a dictionary, forming as available word that exists in a text to form is called a dictionary. So one thing we should know is that this bag of word is sparse, meaning that in machine matrix, we know this is from of matrix, but this is a sparse matrix, and some machine learning algorithm doesn't work well with sparse matrix. And so there is better way to do something like that to convert it from non-sparse. But let's just look at how can we create this bag of words. So we talk about we can use what is called count vectorizer in scikit-learn given any text, and we call count vectorizer. So here we create an object called count, and now we fit transform on this document we have, and now we can see, where do we see? Okay, yeah, we can see like, this object. And now when we send this back and forth to array, we can see these sentences, these 3 sentences are now turned into sequence of numbers. So this sequence of numbers are what machine learning algorithm can understand to train to do training. Right. So but this, what we create here, is called what we call 1 gram model. This bag of word is called 1 gram, but there is a generalization of 1 gram called n gram, where, for example, you can see this is an example. The sun is shining. We divide in 1 1 1, but we can divide into maybe 2 2 word. So in that case, whenever we see something like this not good, we know that not good is it's not positive, not bad is not negative. So that way it can help us to understand more context. So in that case, you can specify, when you are creating a count vectorizer, you can specify the n gram range you want to use. So here we say 2 by 2. It means like you want to use, you can see the sun is shining. You can see this is it. So this is called n gram. Yeah, Falalu, go on. Falalu, you have question?
Hello.
Yes, Falalu.
When it comes to forming this kind of vocabulary, there are words. Yes, there are words that are dual
Falalu,
in nature.
network.
Can you hear me? Yes, there are words that are dual. For example, you can have one word, so there is some kind of space between the words. So it, separating them using this kind of
Falalu, I think your network is somehow, not stable. Okay, so Falalu, if you can, change position and unmute again, because we cannot hear you and it's making some kind of noise. So let us know if you are in better position.
I think I understood where it's coming from.
Yes.
Like at times you have combination of 2 words to form a word. So I think that's his question. How can you separate it from this one?
Right. So for instance, let's say, give me an example. Just maybe a particular word separated by a hyphen, maybe, right? Oh, yeah. So yeah, Falalu is talking, okay, words like New York. So yeah, so if we look at this, so let's look at something. So you can see like some of the stuff argument you have here. If you want to do the count vectorizer, there are a lot of stuff. So for example here, strip accent, if you want to strip accent, if you want to do that, if you want to lowercase, if you want to do tokenization, if you want to do the token pattern, for example, while I said, sometimes you can see a word, 2 words separated by hyphen, something like that. So you can describe the pattern of word that is valid, those that are not valid. This is the n gram range that I mentioned. Any 1 to 1, which is using 1 gram. Analyzer, string word, if you want. Minimum maximum features, vocabulary, binary. Okay, so I think for the question from Falalu, New York, you can see this is somehow kind of it's not it's not a single word, but a kind of combination that gives some kind of proper noun. I'm not sure this token either does that, but for for machine learning, deep learning tokenizers, for deep learning, they can understand what is proper noun, they can understand a word, they can understand, but this one, they are not intelligible, I think, to do that. So if you look at this analyzer, it only do word, only word. So new is a word, york is a word. So this tokenizer, this stuff, actually do, for what? So, but you can specify a token pattern using regular expression that you want to use. Yeah. So for a count vectorizer to be intelligible, to separate like New York, new is new only, New York is a single word. It means it needs to be trained, a trained tokenizer, a train using that corpus in deep learning, for example. But I think for this one, it's not intelligible, but yeah, maybe we can check again. But this is what I think I have on top of my head. Anyone want to add something regarding this, or question or contribution? Okay, so yeah, so that's this. We also discuss about this. Okay, yeah, this is what I just explained. But that's what we call n-gram. No, Lemmatida serves different purpose. Lemmatida and stemma, they serve different purpose. Yeah, so more or less similar purpose, I can say. So now here we have seen what we call bag of word that allow us to create. But the problem is this bag of word is that it does not actually, it just create a word. It does not show any relationship between words, or what that is important or not important. So there is another approach called TF-IDF that, give words with higher, with higher frequency that occur in text that does not have quite many useful meaning, small number of, probability or small percentage, and those with the more important. We discussed this last week, and here this is how we can do that. It's called TF-IDF transformer. And for us to create TF-IDF transformer, there are many arguments here. We can see use IDF, normalization, and smoothing based on this formula. So that's what we discussed. And why TF-IDF beta representation than bag of word. So these are some of the reasons. Bag of word just creates set of vectors containing count, only count of occurrence, while TF-IDF contain information on the more important word and less important ones. So for example, is the bag of word does not differentiate between maybe beautiful, excellent, fantastic, and the word is the, she doesn't differentiate between these. But we want a better way where a model can understand this. So TF-IDF, a differentiate between that. So that's why TF-IDF will be a better suited way. But all of them, they are vectorization techniques, taking a text and form it into some sequence of numbers. But if you go to some chapters, if you go to deep learning, we'll see some other better approach, such as word embedding and using word to back and stuff like that. So that is about that. We talk about cleaning text. So if you want to do anything, we need to clean our data. So for example, we quite all know that the data set that come from review or Twitter or Facebook need to be cleaned. So you need to work on that. So this is what we discussed. For example, given this is an example, you can see there is, tag, so we need to clean it. And for that, here we create a function using regjs that do some cleaning stuff, remove white space, return lower to low, higher case to lower. The reason why we want to do lowering is that if I have the word lob, if I have the word lob, if I have the word love, will be different from the word love. So you can see we want to make sure that love and love are the same, so that we will count if we get a text if it contains it. So we need to do lowercase. So that's why. So there, yeah. So this is basically the function to do that. And when we do the cleaning and for single text here, the function, and now here we do apply. preprocessor, which is a function here. Preprocessor, you can see that, which is a function here. We apply this preprocessor on the whole review. This is the data frame. The review applied this function to hold the review. And now here we clean the data. So we can see like it's clean, or like here before that it's not clean. So this is one thing that you should all know. Given any data, this is the even first step you need to do. Given any data, before you start doing any modeling, you need to clean it, put it in a beta shape that you will work toward it. So that's what we discussed there. And now we move to the what you call tokenization, where where you're gonna have taking a text and bring it to token. We have already seen previously, like even in the context, what is it? While we are creating this bag of word, you can specify the tokenizer. But here we they are talking about showing us what is the meaning of tokenization. So given here, there is what is called text split in Python. So this is a function we just create tokenizer. So given this one, it do this. But the problem here we can see is that run and running, they are the same word, but they are different. So in NLP, we do what is called stemming to make sure that this run and running as same word. So here we import what is called stemmer, Porter stemmer from NLTK, and now we create an object called Porter from stemmer, and now we create a function called tokenizer Porter. So we can see here with word in this, after it does splitting this word, after this splitting, can you see this tokenizer? This split, text split. So for word in this, return the statement. So, and here given this, you can see this is run and run. So this is Porter stemmer, which stem the word to its root meaning. We also discuss about stop word removal. So this is something in NLP where given words that are not quite useful, we remove them. So this is downloaded here. And now from NLTK give us stop word, English stop word, where we can see them. These are English stop words. So these are words that does not have quite useful meaning when we are doing NLP. So we intend to remove them basically because they don't contribute to any useful discussion. Yeah, but it is also domain dependent. For example, if you are doing machine translation, you don't need to remove these guys. Even though if you are doing deep learning, we don't remove even stop words. So we just use them. The deep learning algorithm, they are so powerful, they understand this stuff. Right, so yeah, so that's it. So now after doing all this, understanding all those stuff that we need to do, now we want to train our machine learning model. So training a logistic regression. So we will take everything that we just said and now put it together in one single code. So here, given a data set, this is our data set from 0 to 5,000. This is sentiment, this is review. You were asked, train this data for sentiment classification, right? All what I have said before, you will see the applications here. Now, assume that this is just a data set. You just load a data set, and now this is it. Now, how can you start doing it? Before we train a machine learning model, remember we need to do train test split, right? So this is a train test split. Remember here he is not using scikit-learn, but we all know we can use scikit-learn, right, to do the division. So what he's doing here is that xtrain df lock, meaning use take the review column. Can you see the review? I believe we all are all patternista. So what is lock? Given lock, if you are given a data frame and you want to do subsetting, I don't need to do more explanation. I think we all know we are good enough with Python. So lock here, what it means here is that here you can see we put dash here. We didn't put any number here, and we put another number here, right? So meaning that we are subsetting the row from the beginning to 25,000, and give me the values. So which is excellent. So when I run this guy, can you? Okay, when I run it, yeah, you can see this is 25,000 reviews for training. Can you see that? And now here you can see xtrain. This is y train. Now xtrain the first 25,000 from the beginning to the 25,000, and now takes the sentiment. So it's saying like from here, Zua, if let's assume here is 1, the first beginning, and here is 25,000. Here is 25,000. So what you do is that this guy will take from this, that is from here, Zua here, only this column from here to here, that is 25,000. That is what logs is doing. Let me show us like an example for those people that are not familiar or forget what logs is. So, you know, given a data frame like this, can you see DF? So how can you like, you know, take, you know, a column here. So here, for example, you have df.log by far. So here, if we look at them here, single level df. Yeah, here we can see we take by far. It gives us only a row 4, 5 with this. But let me see where they take an example of, yeah. No, they don't have an example. Oh, yeah, something like this. So this is an example I want. So if you look at this one here, for example, df.log, look at the data frame. We have mark speed, shield, first column, second column. We have first row, second row, third row, right? Now, assume I want to take from this row and one row, first a row. What I will need to do is, you can see this is it. df.log cover viper. That is from the beginning of the row, you want this one to here. I want to take from here to here. Then that is what will come first. Can you see that? This is the beginning, this is the end. And now here you specify the column, mark speed. So it is telling us that, so here it is telling us that from the beginning, if we omit, we didn't put anything, it means from the beginning. So it means from the beginning to 25,000 and take column review. So if I take this guy first, remember, if I take this guy first, I run this guy, and I say call Xtrain. Yeah, can you see it give me this? Right, it gave me this. That is this column of review. And you can see it's 25,000. Can you see 25,000 from 0 to 1, 25,000? But when we are training machine learning model, scikit-learn, we don't give it because this is a data frame, right? Let's look at what is this. Can you see this is a pandas, you know, series. This is a pandas series, right? But the machine learning sklearn don't accept this as an input. What they accept is an array. So we can say, okay, give us values. That is because if you look at them here, what you can see is like there is, you know, they have reviewed the name. This one is, but we only need value. So we call this guy here. When we call this guy, no, okay. When we call this guy here, we can see that it gives us an array, right? Can you see that it is an array? Yeah, so you can see the data type is object. So this means that this is the kind of thing the machine learning algorithm accept only array. So you can do this. So that's why here we are doing this something like you know, dot values in H1. So here we create the Xtrain and Ytrain. So the first one we take this one here, 25 this, and put it Xtrain. The first sentiment 25 here and put it as Ytrain. And the last 25 we put it, can you see from the beginning of 25,000, that is the Karshan one data, okay, to the last here. Take it. So this is what we did here, the data. I just explained this one because we already familiar with using trend tests, using scikit-learn to automatically divide. So this one is manual. Any question before we move on? Any question? Shamsuddin, any question?
Oh, so it's crystal clear.
Right, cool. So now we are good enough. We can now move on to train our logistic regression. So we import pipeline, and we already have seen pipeline, and we import logistic regression. We import what is called TF-IDF vectorizer. Because remember, we are given text. This is a text. Then we need to combine it into those zeros and into numbers. Now we import grid search that we want to use grid CB to find the optimal parameters to train our model. Now, so here we have what is called TF-IDF vectorizer. So remember here, you know, we do something like this here, where we yeah. So here you can see we have, you know, count vector array here, where we transform, it makes this one here, what we discussed previously. Now, yeah, you can see here we import count vector array and now fit transform, right? Then that's how we get this one, right? So how can we do, and for the other one, TF-IDF transformer, can you see that? TF-IDF transformer, which basically is giving us this format. This is it. So are we going to use TF-IDF transformer, which is IDF, which use some sense, given you know, what is useful, more weight, and what is not useful, less weight? Are we going to use this TF-IDF transformer, or are we going to use count vector either? That is the question. So let's look at what this is saying. So here we're going to use what is called TF-IDF vectorizer. TF-IDF vectorizer. So what is this? So it converts a collection of raw document to a matrix of TF-IDF features. So what it does is it is equivalent to doing count vectorizer followed by TF-IDF transformer. So it creates like you know, it creates a matrix of our representation of text, and yeah, and using also TF-IDF transformer. So it implements both these two. Yeah, it make the count vectorizer and also make importance one with the higher weight and less important with higher weight. If you look at this one here, there are a lot of, you know, argument you want to work on or give it, but you can look at it here. There are a lot of arguments, so we may not see them here. From SQL and TF, you can see them a lot. So anyway, so this is what we're gonna do. So here you can see the apostrophe accent. No, we say no. Lowercase, no, don't lowercase it. Preprocessor, don't do any preprocessing. So this is something that you know, we want to do. So we call this one TF-IDF. So in essence, now we create a function or an object that will allow us to change our text, given any text like this, to convert into matrix. So it will convert all these text into some kind of matrix representation that will be used for training machine learning. Okay, that is this, but we want to use grid search CB. Do we all remember what is grid search CB, or we forget? Do we all remember grid search CB, or we forgot? Alan Shamsu, do you remember, or Amanta?
That's the concept I don't contact. The name is familiar, but
so
the concept is a bit back.
Yeah, cool. So
My doctor, it's not a problem. We can check it later.
Yeah, so grid search CB, you remember, like proceed. We have different kind of parameters when we are training a model. Grid search CB is used to select the best optimal parameters, hyperparameters. You remember? So that's what we're gonna use. So here we gonna specify some parameters. So here we said, you can see I have two dictionaries. I have two dictionaries. This is a dictionary. Can you see it inside a list? This is another dictionary. So here, what we're gonna do is like, in the first dictionary, I said vector n-gram range, the n-gram range. Remember, if I'm gonna use like z only one, is only one, or the is that is bigram. So here, what are we doing here? Is it bigram or unigram? You can tell us what is the representation of this? What is it? What is the meaning of this?
Unigram.
Unigram, exactly. So we are using unigram. So we want to train a machine learning model. We use unigram. Stop word. I said no, stop, none. So if you look at this one here, I use something called stop, right? This is a list. Can you see that? Stop and none. So if you go back here, you can see like, I have what is called stop. What is stop? That is list of stop word in English. Can you see? Because my problem is in English. it means I want to remove this top word, right? Or something like that. So I give this object here, stop. Can you see that? And here I have something called none, right? Now here I have vectorizer, tokenizer that I want to use. I have tokenizer, I have schema here, tokenizer. So let me go back to all these object that I have already defined. If you go back, yeah, so if you go back here, you can see here, I already defined something called tokenizer, which basically take each and every word and put it and tokenize it, like just give me a single word. Token, from token, it's just like a verb, tokenize, make each word to stand on itself. So you can see like this is a token, like it's a token, running is a token, and it's a token. So here is a token. But here we have schema. So schema, it means what schema does is it's not tokenizing, it's stemming, taking each word to it is unique for root word, like running, it turn it to run. Can you see that? So we need to do to tokenize, like to put in them in a single word. And now then we can use schema to do the same. Yeah, so here you can see like this tokenizer, I just use text split to divide the text into sentences, and now I call it here inside my POTA schema. You can see it. So this is something that here we have. Can you see tokenizer and POTA? And now here is penalty, which is basically we said L1 and L2. So what is the meaning of this L1 and L2? So because these are, remember in grid search CV, we define all hyperparameters. Oh, this is the one I'm using. We define all our hyperparameters in this, in grid search CV, and we ask the machine learning model to select which one is the best. For example, you can see here, I may say, okay, I want to use two here, right? Or I want to, so grid search CV allow you to use different option of hyperparameter to ask your machine learning model to select the best one. And here I say I want to do the L2, and now here, because I'm using logistic regression has parameters that hyperparameter I specify. This is the one I want to use. Yep. I also have another one which is the same. I said, okay, here you can see tokenizer no stemming. I said use IDF, false, don't use IDF, but here is true. Norm L2. So these are some of the hyperparameter we specified based on logistic regression, and now we want to train the machine learning model. So now here we define a pipeline. Remember, a pipeline is to define some kind of operation you want to work on your text, and now the last one is your algorithm. So because we want to change all this text from this to sequence of numbers, then this is what will be applied on it. Remember, yeah, so this is what we have. Pipeline vectorization, which is TF-IDF that we already create here. Can you see that TF-IDF? And now our algorithm in the pipeline, remember, all the pre-processing comes first, then the last what will come will be the algorithm. So we have logistic regression, and the algorithm here we select is solver. So logistic regression has different kind of algorithm that you can select. If you look at it like solver, if you look at the solver here, yeah, solver, Newton, LFG, linear, YS, these are all that. The default is LBFGS, so you can select anyone. So now we are free now to train our model. Grid search CV, you need to put your algorithm, that is the pipeline, which is this one. This is it. But this is the pipeline, but what are some of the hyperparameters that are going to be used? So this is what we have. So in grid search CV, you specify first argument, the argument, if you have hyperparameters, these are the hyperparameters. And now here we say we are good using accuracy, and now cross validation 5, n job -1, meaning use the available course on the computer. That is the only code here that will train your machine learning algorithm for sentiment analysis. Now, when we have this, putting this one -1 allow us to use many courses. So I think I have, for me, I have, is it 8 course or whatsoever course? Let me see how many got 10 cores. Oh. Let me see. Is it 8 or no? Oh, sorry. I'm using it outside. I'm talking about it's inside the algorithm. Yeah, I have 8 core. We will see it later. So yeah, so here we create now grid search CB object here after training, and now we are ready. So here we can say, okay, grid search CB, grid search CB, LRTF IDF fit. We now fit on the training data. So here we can see we create a grid search CB. That is, we fit it. Now we need to fit this grid search CB object on the training data. So here we create on the training data and now fitting on this. So here we have it here. Okay, now we all know that what is the meaning of grid search CB. Grid search CB allows you to select the best hyperparameter you want to train your machine learning model. Now let's look at the grid search best params. So best params underscore allow you to see the best parameters that you can train the model. So here we can see best params. This is this, penalty is L2, 1 and 1, stop word none, without stop word. So these are basically our base hyperparameter. So we can use this base hyperparameter to just retrain our machine learning model. We can also see like the base score. So the base score using grid search CB is 0.87. Yeah, we can also fit our model using test data. So here X test as S test. You see, but here we need to assign the base estimator. So because in grid search CB you have different kind of estimator that you are working on, maybe not one algorithm, different kind of algorithm. So here for you to find the score on test data, you need to use this best estimator score. Can you see best estimator score, and now assign it into any different object that can be used to call on score object. So this allow you to see the score on your test data. But this one is just a score, CV score. It's not, it's on training data. This one is your CV score on training data. But this one is what is on test data. That's just why here we find the best estimator and now assign it to an object, and now use the best estimator to find the score on test data. But if you look at this one, we just call our object best score. What is the best score on this, on the training data? So this gives us the accuracy on training data, right? But this one gives us the accuracy on test data. Right. That is all. You train your machine learning model to train sentiment classifier. Question? Saminu, any question?
No.
Okay. Are we good?
Dr. Waja n-gram, no?
Yes.
I can see one by one.
Mm-hmm.
So is it representing row column structure, or what does it stand for?
So what this means is that remember here while we are creating the count vectorizer, if you look at this in here, we said, okay, count vectorizer, we have only one word, the sun. But when we want to have bigram, like the sun is, then what we need to do is to specify this n-gram range 2 by 2. It means, so if we look at count vectorizer, so look at it, minimum and maximum n. Minimum and maximum n.
Okay.
So the lower and upper boundary of the range of n values for different word n-gram or character n-gram to be extracted. All value of n such as, okay, so what is meaning is this. Now, if, for example, I give this 1 and 2, what will happen is this. It will return the where we have 1 gram, and also it will return the bigram. that is 1 gram and by gram, it will return here. Let me try it, and so that you can see. I see. Can you see? I have 1 gram. Can you see I have 1 gram? Can you see all the 1 gram? And now after it finish all the 1 gram, now it will start doing the bigram. Can you see it? It's 2. So what this means is that the minimum and maximum that you need. I don't know if that makes sense.
Yeah, it's okay. It's okay.
Yeah, good question. Anyone with question, please ask question so that it can be more interactive. Abdurrahman Muhammad, any question?
No question, sir.
Okay. Hajara, any question? Okay. Okay. IT lab, malama murjaci, IT lab mun gane ki zaki sai kin mun gane sunan naki ai. So any question kin ga, do you understand malama? Hold the question.
Question.
Okay. So it means mun gane. So okay. So this is just yes.
If my data set is in a different language, am I going to still use the stopwords, the same stopwords you use here?
No. So here the stopword we can see is like German, we have like English, but we don't have stopword for Hausa. So you need to find stopword for Hausa to use to remove. Yeah, we don't have stopword for Hausa, but we have stopword in our GitHub, I think, in our work that we did for Nigerian sentiment analysis. We have stopword for Hausa, so you can just use. So, but this NLTK, they don't have, stopword, NLTK, they don't have stopword.
So if I'm to use a Hausa data set, then how do I go about it?
Yeah, so it's still something. Just read. You need to read the, you need to read the stopword if it is CSV or whatsoever, so that it can be in something like this list. And now you can just assign it to some value stop, and now you can call it here the something. So just reading it is still the same. Falalu. Maybe one of us, maybe we from House NLP, we can take like a how we
ina gama if I can say me no stop so language din da yake so ko masu yawa so masa su.
So this will be like a good project. So I think we started a project in Masakani about stopword, African stopword. So you can see like this stuff from NLTK, there are no African stopword. So it will be a good project for somebody just to create a stopword, and maybe if it is possible to integrate it into the NLTK, or just to create like a Python package with African stopword. That would be a cool project. Okay. Yeah. Anyone with question? Okay. So then this is comment. What he does here is just a comment, just telling us like this CB accuracy, because we are, using because we are doing, CB, which is cross validation. So remember, in cross validation, what we are doing is like we are dividing the data into different fold. So the CB here accuracy is like the accuracy across the 5-fold, the mean. So what he does here is just like trying to show us like, okay, this is give an example that this is a score on 1-fold, 2-fold, 2nd-fold, 3rd-fold, 5th-fold. Because we are in CB, 5 CB, and now the mean, taking the mean, the best score we can see 0.48, but taking the mean of all of them also give us 0.48. So this is not in the book. It's just telling us we already know that the CB is taking the mean, because when you're saying using cross validation, you are using 5-fold and you are finding the accuracy on each fold. So this is the first fold, 2nd fold. What is the accuracy? This is the second accuracy. Now, the best score, when we have this best score, is giving us a single number. It means it's taking the mean of this. So here you show us like taking the mean, calculating validation score, and now taking the mean is saying that you should also remember that. Okay. Yeah. So Let's move on to another, something called working with bigger data, online algorithm, and what is called out of core learning. So sometimes it's difficult because maybe if any one of you, anyone try to run this algorithm, if you have a single core, or, it may take a long time to run it right from your own end. Anybody that try to, run this and find it, how long it takes? Hello, anyone, anybody that try to do that? Bound running now. Okay, so what I'm trying to say is this: if, for example, yeah. So what I'm trying to say, like, let's look at this. So you can see, like, I have 10 cores in my computer. I have 10 core. My computer has a 10 core. Now, if your computer has maybe, Saminu, how many cores do you have? Okay, Samina Shivana. So if you have like a computer with less cores, it will take quite a long to process data, which is 50,000 to it. It may even hang, right? So there is a solution which is called, out of core learning, because all those data 50,000 may not be useful on your core, on your machine to process it. So that's why I say it is computationally quite essential to consider the future vectors of 50,000 movie review during research. So in many real world, it is uncommon to work with even large data. So since not everyone has supercomputer, we will now apply a technique called out of core learning. Out of core, which allow us to work with large data set by fitting the classifier incrementally on the batches of the data set. This is what we call out of core. So let's look at it. Now, here I have a big data set, gigantic. What you need to do is divide this data into batches. So if it is 1 million, divide it into 100, 100, 100, 100, 100, 100, 100, I mean 100,000, 100,000, something like that. If it is 50,000, divide it into 5,000, 5,000, 5,000, 5,000, something like that. Now, when you divide this, your data, it is on your disk, because your disk, you can have 1 terabyte, right, on this, so you can store a lot of data. But your memory cannot hold this 50 gig data in your memory. So what you need to do is divide your data and now process them batch by batch. So you take this batch, put it in memory, train your model, take this batch, put it in memory, train it, put this batch in memory, train it. So this is what we call out of core learning, because you cannot train all this in this. Yeah. So this is it. Out of core learning refers to the machine learning algorithm working with data that cannot fit into the memory of a single machine, but can easily fit into some data storage such as hard disk. So here, this is a hard disk, can fit easily to a hard disk, because your hard disk is 5,000 gig, 1 terabyte. So to do that, there are some techniques. So here it's tokenization that we discussed previously. And now here, this is what we call, creating a generator function. I don't know any one of you, do you know generator functions in Python? Anybody know, familiar with generator functions? Anybody? Nobody? Ah. Okay, so this is something. Okay, let me see if I can get an example so that I can show us a generator function. Okay, so in Python, something like this. Do we all know what is called yield here? So let me do something like this. Oh, this is the first concept you hear about what is generator function. Okay, so energy, so Okay, so here I have a function called myGen. You can see I have some number here. I have many objects here. I have something called yield n because I have n is equals to 1. Now I have increased my n, that is n equals to 2 here. And I have yield n. I have n is equals to 3 here. I have yield n, right? Now let's assume here I have an object here. I create, because this is a function here called myGen. Can we see myGen? Now here I can use a function, a method called next. Now let's look at what will happen. Let me show you. Next. So can you see it gives me, the first item? What about if I put next? Can you see it give me the second item? Can you see it give me the next third item? These are called generator functions in Python. I think we are not here for Python, but just give the main idea why we have these. Yep. So what we want here is that I want to create these batches, this batch. So if I take this batch, how can I take the next batch? So I want to use generator telling me, give me the next, it will give me this one, give me the next. So this is the purpose of this one, creating the generator function, stream doc. So this is it. Okay, you can see this is a keyword that I talked to you about, generator. So any function with this is called a generator function. So I really, maybe I will bring back our daily Python practice where we will be learning practice Python. It keeps us on a breeze with the, Python, because like if you are doing this machine learning every day, you will see something in Python. So if you don't know it, it will be difficult. So maybe we need to bring back.
I have used something similar to that.
Sorry?
Time series generator. I have used time series generator, but it works similar to
Okay.
this.
Okay.
Time series generator.
Okay, cool.
That is this, but not like this.
So yeah,
it also prediction in this batches. I mean.
Okay, so here is it. So this is like but this one here we create a batches. So here you can say get a mini batch. So here using the mini batch, here we can do that. So this is just like trying to tell you how that thing works. So this is also training, but they say like unfortunately you cannot use count vectorizer for out of core learning. So we cannot use count vectorizer. So here they use something called hashing vector. And now the hashing vector, these are some of the stuff we did. So we create a vector. And now with this vector, now we can now, create, use a classifier called SGCD classifier. So we use this SGD classifier to train the algorithm. And now here, this is a log loss. And now we train the classifier. And now finally, train the model using get mini batch, and transform as well. But the main idea here, just to take away, you don't need to necessarily, I just tell you what the main idea is. So you don't need necessarily to, understand this out of column, but you can go through over it. But I give you the highlight of what it is. But the main important things, I think you just understand how we can do sentiment analysis there. And we will stop here. We will stop here tomorrow. We will do what is called, topic modeling. But as I said here, here we can see we use somehow kind of bag upward approach where we use, bag upward to train machine learning model. But there are better approach such as what to beg and many other things, which we will see maybe from chapter 10 doing deep learning. The